Morning, everyone. My name is Yuri Mytko. I'm the Chief Marketing Officer at CarbiCrete. We're a carbon removal technology company based in Montreal, Canada. And our technology enables the production of cement-free masonry and hardscape products. In our technology, we replace 100% of the cement in masonry and hardscape products using a material called steel slag, which is a byproduct of the steel making process, which reacts with carbon dioxide in a mineralization process during the curing of the concrete. CarbiCrete was founded in 2016 in Montreal based on technology that was developed at McGill University by our esteemed moderator, Mirdad Mekhuchian, who is now the Chief Technology Officer of the company. Since incorporation, we've grown to a team of about 50 people. We've raised just over $40 million from a pretty diverse investor base, including both financial investors, but also a few key strategic investors, both upstream and downstream. I don't think I need to tell anyone in this room but the issues we're facing connected to cement-related emissions. They account for about 8% of the world's GHG emissions. And one of the reasons that the cement and concrete industries are considered to be amongst the hardest to abate industries is because of the lack of viable alternatives to cement as a binder in concrete. That said, there are a number of interesting new pathways that will reduce our reliance on cement as a necessary feedstock in concrete making, and our solution is just one of them. So, in our process, 100% of the cement in masonry and hardscape products is replaced by a steel slag. I'll probably repeat this a couple of times over the course of the conversation, but just to be very clear, steel slag is not granulated blast furnace slag. There are wholly different materials that are created at different points in the steel making process. So by the time the slag, which is our feedstock, arrives at a concrete plant, it's been ground to a consistency that's very similar to cement, so it's a pretty fine powder, and it's used as a drop-in replacement for cement. We use all the same standard equipment, so same mixer, same molds, same block making machine. The difference in the process really comes at the curing stage, where we put the freshly pressed concrete products into a CO2 curing chamber, where we introduce carbon dioxide to the product. And 24 hours after the products go into the curing chamber, they're ready to use. So they've reached full strength, they're ready to ship, ready to use in any construction project. So what occurs inside the chamber during curing is that the carbon dioxide becomes a solid mineral when it reacts with a steel slag in the presence of water. So we're essentially making limestone in the products as they're curing. And at the same time, the carbon dioxide is removed from the atmosphere permanently. So the most common questions we get around our process are, first, where does the CO2 come from? Second, can it ever be re-released into the atmosphere? And then third, hey, hasn't steel slag been used in concrete making for ages? So in answer to the first question, we're largely source agnostic as far as the CO2 goes. In our particular instance right now, with our current customer, we're buying CO2 that is being captured at an ethanol plant. So it's part of it's biogenic CO2, it's part of the natural carbon cycle, but it could just as easily come from some industrial process. It could be coming from from flue gas. It can be captured at a steel mill. It could be captured at a cement plant. And at the same time, it could be coming from, being pulled directly from the air through some DAC solution. It really doesn't matter to us where the CO2 comes from. It may matter from a carbon accounting perspective, but as far as its usability in our process, it really doesn't make a difference. And then in response to the second question, it cannot be released. Mineralization is among the most permanent forms of removal. You would have to heat a concrete product to probably well north of 500 degrees centigrade in order to re-release the CO2 into the atmosphere. As far as the question around steel slag and its usability in concrete goes, granulated or ground granulated blast furnace slag has been used, as we all know, as an SCM for decades. And GGBFS is created during the iron making process. It's created by blast furnaces. And it's highly reactive with water, and that's why it's just like cement is, and that's why it's been used as an SCM. Steel slag, on the other hand, is produced during the steel making process, which happens later. It's made in either electric arc furnaces, EAF, or basic oxygen furnaces, BOF. And the main difference when we're talking about GGBFS and steel slag is that steel slag does not react well with water. It's got very limited hydraulic properties. And so in order for it to act as a binder in concrete, it needs carbon dioxide. In terms of the carbon impact of this carbonation technology, if we look at a unit level, if we take an 18 kilogram CMU, a standard 40-pound block, we're talking about a kilogram and a half of avoided emissions by not using cement per block, and then anywhere between half a kilogram to a kilogram of carbon dioxide that is permanently removed during the mineralization process. In addition to the environmental benefits that come with this carbonation technology, the implementation of this technology at a customer site also brings significant business value. So first, provides them with a hedge against rising cement prices. It allows them to win jobs that require low carbon or lower carbon materials. They can also share in the value of the carbon credits that are generated through the avoidance and removal of carbon dioxide. And they've got a faster curing product. So within 24 hours, like I mentioned, you've got a product that's usable at a construction site. In terms of our specific path to commercialization, we were very fortunate to be located in Canada, where we were able to leverage a fair amount of both provincial and federal funding from the government, which allowed us to implement a pilot project at a industrial partner site. That industrial partner has since become our first licensing customer. And what it allowed us to do is basically get out of the lab and prove the technology out at commercial scale. That company's Patio Drummond. They're a hardscape producer just about an hour outside of Montreal. And they produce quite a wide range of products, but traditionally weren't really block makers. And so that was a market that they were interested in becoming more active in. And so it was a nice opportunity for us as they were retrofitting their plant or converting their plant into more of a block-focused operation. We were able to install our curing system. And over a 36-month period, we were able to basically optimize our curing process, the design mix, also value engineer the chambers that went through a number of different iterations over the course of that 36-month period. And then at the end of that, we were producing product that meets or exceeds all relevant industry performance requirements. And then last fall, we basically moved out of pilot production and into commercial production. Patio Drummond was satisfied with the results, and our focus then really turned to helping them sell these new low-carbon products to the market. As far as implementation goes, the feedback from Patio Drummond was hugely positive. It's not a terribly disruptive process. We're using, because we're leveraging existing infrastructure, really the only change beyond the installation of the chambers is ensuring that the finger cart can move these new products over to where the carbonation chambers are, as opposed to just the regular chambers. Patio Drummond has since moved on to additional products. So they are now using the CarbiCrete technology to produce a range of different products. As you can see, they're mostly focused on, at the moment, landscaping products for the retail market, but what we are doing with them is developing new products more focused on the professional market, where there's a lot more focus on things like aesthetics, so color, finish, that sort of thing. A much longer product development cycle, but we're hoping to be able to announce the launch of those products in the coming months. A key part of commercializing this process is our cooperative marketing program. So this is essentially aimed at the architectural, engineering, and construction community. What we do is we provide our licensees with co-branded materials and a lot of messaging that allows them to basically talk more intelligently about the carbon benefits and the environmental attributes of the process. They may have pre-existing relationships in the AEC community, but this is very new vocabulary for them, and so what we're able to do is provide them with the necessary language. And then, of course, all of this is reinforced by our own corporate communications, so our licensees benefit from the messaging and content that we're putting out over our own platforms and channels. This is just an example of the kind of messaging that we target the AEC community with. It's mostly focused on providing assurance that all of these environmental benefits don't come with any kind of compromise on performance. We've also been very focused on getting end-user feedback. So we've had a number of projects commissioned and been able to gather feedback from masons who are actually using the product. And so far, the reactions have been hugely positive, and these messages really tend to resonate with the AEC community and also with our potential licensees. EPDs, as we all know, are becoming more and more important. And so we were happy to be able to work with Climate Earth, the leading provider of EPDs in the concrete space, for a site and product-specific EPD, which we're about to publish. Should be published, I hope, this week. We were very pleased with the results, so we've got a GWP, or a global warming potential, which is a key metric of the EPD that is significantly lower than any other concrete product that we've seen for which an EPD currently exists. In terms of what we've actually done with the blocks that have been produced, so a large chunk of them have been sent to third parties for verification and validation. Some of those are certification bodies across the different geographies that we're interested in operating in, but also potential licensees who want to first have a firsthand testing of the product. Patio Drummond has provided a fair number of blocks for some community projects local to them in Drummondville, Quebec. We've also provided product to the SpecBix Bricklayer 500 competition, or the regional competition for 2 years running. So the CMUs act as a base for the bricks, and that's also allowed us to gather a little bit of feedback in terms of what it's like to handle the product. And then currently, we've got our first real construction project that is ongoing just outside of Toronto. Aecon is a large Canadian construction and infrastructure company. They have an innovation center just outside of Toronto, and they are building a net zero storage facility there. And so they're using CarbiCrete product there. So next time we present here, hopefully we'll be able to have some visuals of that. And then in terms of what's next for us in our commercialization efforts, as I mentioned, we're working on new products with Patio Drummond that we're hoping to be able to launch shortly. We're also installing some additional capacity there, so they've been really pleased with their experience, and they're installing more chambers right now. We've got another customer coming online in Ontario in January of 2025. They're called Canal Block. They're a block maker in Port Colborne, Ontario, just outside of Toronto. We've got a number of ongoing discussions with potential licensees, both in North America and abroad. We're also working on a pilot project with Saint-Gobain, the large French construction materials company that is an investor in CarbiCrete. And we are also exploring a number of different pathways to a CarbiCrete dedicated facility in the US, which we're hoping to be able to announce shortly. Thank you very much.
Yeah, good morning, Matt Dalkey from Lafarge, Canada. You mentioned that you can use EAF or BOF slags. Which one are you using, or are you using a blend? And is there any pre-treatment of that material other than grinding and preparation for your process?
It's really just grinding. We've used EAF, we've used BOF, we've used ladle slag, stainless steel slag. So we've not blended them. Typically, when we're sourcing, there's one process in place at a steel mill, and so it's not being blended at the moment.
Hi, great presentation. I just wanted to ask, what are your mechanical properties and long-term durability in comparison to Portland cement?
Myrdad, do you want to answer that question? I happen to have our CTO here, so.
I mean, the performance from short-term, long-term, either same or even better. Again, depends on what type of properties you are talking about. You are talking about the strength, you are talking about drying shrinkage, you are talking about water absorption. But the properties, the durability properties seems better compared to the cement-based product, including freeze and thaw resistance, perhaps. You know, that's the most challenging, let's say, performance. But our products works better and has better performance compared to cement properties.
Thank you.
Thanks. Thank you. Thanks, Yuri. Thanks.